तरह के क्वेश्चन पे है, एक बी है एक सी है। ए का तो नेचर अलग है। बी और सी में जो है उसमें आपको बी में जनरल क्वेश्चन आते हैं, जो आपके टॉपिक्स है उसे जनरल क्वेश्चन आते हैं। सी में ऑलवेज एनालिटिकल क्वेश्चन आता है। हम बार बार बोल रहे हैं एनालिटिकल मतलब कि जो आपके बेसिक प्रिंसिपल्स पे आधारित होंगे, ठीक है, वो आते हैं। तो पहले तो आपको कॉन्सेप्ट क्लियर होना चाहिए। जब तक कॉन्सेप्ट क्लियर नहीं होगा आपका सी बनेगा ही नहीं। तो फर्स्ट क्लास में, इन लास्ट क्लास, हमने आपको क्या बतलाया था? थ्योरेटिकल एस्पेक्ट्स। इसके थ्योरेटिकल एस्पेक्ट्स को हमने बतलाया था। चेंज ऑफ एनर्जी, इंथैल्पी, एंट्रोपी, गिब्स फ्री एनर्जी, रिएक्शंस, रेट ऑफ रिएक्शंस, ये सब बातें हुई। उसी कंपोनेंट को द सेम थ्योरेटिकल कॉन्सेप्ट्स आर डिस्क्राइब्ड टुडे इन द फॉर्म ऑफ ग्राफ्स एंड इक्वेशंस एंड लेटर ऑन सम बेसिक एग्जांपल्स फॉर द कैलकुलेशन। ठीक है, तो फर्स्ट वन विच वी डिस्कस्ड इन लास्ट क्लास इज द इंथैल्पी। Enthalpy. First one was the enthalpy. First क्या था? Enthalpy था. First one was enthalpy. And enthalpy, we simply say that the heat contents present in any system. Simply, it is represented as the heat content present in any system, and it is represented by H. And the change of the enthalpy is represented by delta H. And for the formula, I referred that delta H or the change of energy delta E is B minus A, and on the B minus A रोहन को थोड़ा सा समस्या था, and one viewer represented in the my YouTube and ask the same question, that why we write the B minus A. And one thing here, that the minus here we are using the minus. The minus is the not algebraic sign. ये algebraic sign नहीं है. It is the change in the potential of the energy. Potential energy, that potential energy is present in the form of bond energy. Potential energy is present in the form of bond energy. And when we draw a graph here, why I am use a graph here? At first, it represents the energetics level, either the calorie per mole or joule per mole, whatsoever right here, either in the form of calorie or in the form of joule, जो भी लिखना हो. And here the change with time. Change with time. Here, the graph is, if you draw a graph, it is like this. This one represent either A as per the equation described earlier, or actually it represents the reactants. Reactants. It represents the reactants, and it represents the products. It represents the product. It represents the reactant and it represents the product. And here, the change of potential energy, if you consider it, the change of the potential energy is from here to here. Is from here to here. That is minus delta H. This one represents the equilibrium energy. Equilibrium energy. And this one here, from here, it represents activation energy. Activation energy. Clear? That means here in the system, energy is available. Energy is available due to the change of the potential energy from reactants to product. Why we always represent in the formula or in the representation or in the equation, that is product minus reactant. Either you, or in other way, it may be that A plus B is the reactant and C and D is the product. In that condition, you represent C molar plus D molar minus, that is A minus B. That why so? Always you represent at first the product, then represent you the difference of the reactant. And in the explanation, I said that A is converted into B. That means the A is the reactant and B is the product. Why so we represent B minus A? Clear? In second, in sometimes, in second way, if we study the enthalpy, then suppose here the reactant is start the reaction. Here and here it present the product. Present the product 1 and product 2. That means the change of energy is here. And this one is H. In this condition, the potential is regarded as the positive H. And here it is represented that the reaction is endergonic. Endergonic. And here the reaction is exergonic. Sometimes the activation energy, and one thing more here, the change of energy has no impact on the rate of reaction. Here it is only responsible to provide the spontaneously of the reaction. Clear? यहाँ पे कोई दिक्कत नहीं है? चलिए. Comes on the enthalpy. This one was entropy, graphical representation of entropy. Then we comes on the enthalpy. Sorry, this one is the enthalpy. Now we come from the entropy. Second one is the representation of the entropy. Entropy. And in the entropy, we clearly represented that the randomness is increased. Randomness is increased when the thermodynamically the condition is moved from one to another system. That is responsible for the increase of randomness. And if we consider the three stages, for the proper understanding, we consider the three stages. One, the different forms of water. Water का जो different forms है उसको आप दिमाग में लाइए. तो what is the different form? That is the ice. Ice के बाद water के बाद vapor or steam. There are three forms of the water. Likely in the other way, we consider the solvent, solute, solvents and solution. All these three represent the same nature of the enthalpy. Because here, I am asking repeatedly that we use the physical principles or chemical principle in the biological system. If we consider the thermodynamic applicability in the term of heat and work, now it is very difficult to understand properly in the classes of the life science. Of course, the principles are applicable, but in the term of the chemical kinetics, because here in the living system, commonly all the energetics is associated with in the form of, initially in the form of the photonic energy, that is the light energy, and thereafter in the all living systems, it is associated with the bond energy. Maximum potential energy is present in the form of bond energy. And here, the three, if we consider the three stage, that is ice. This one is the ice. Ice is converted into liquid. Ice is converted into liquid, and liquid is converted into vapor. Liquid is converted into vapor. Ice is converted into liquid, and liquid is converted into vapor. That means the stages or system is changed with respect to the increase of the temperature. When you increase the temperature, the system is changed. And here, it is also responsible for the increase of randomness of molecules. Randomness of molecules. Randomness of molecules is increased when we move in the different stages. And likely, if you observe the solutes, this one is the solutes. This one is the solutes. This one is the solvent. And this one is the solution. And here it also represents the three stages. That is the solutes, solvent and solution. And here it is also responsible for the increase of randomness. Here it also represents the increase of randomness or entropy. Randomness or entropy. Randomness and entropy, they are increased. That means the value of differences of the entropy, what is the chance for the DS? that is change of the entropy. अगर ये पूछ दिया जाए आपसे एग्जामिनेशन में या कोई है, more than or equal to 0. More than and equal to 0. That means the enthalpy may be positive, may be negative, but the enthalpy and entropy is always more than 0. More than 0. ये 0 से कम कभी भी नहीं होगा. Clear? If we consider in the later forms, suppose it is a system. It is a system. It represents a system in which the different energetics level here from higher to lower energetics. It represents from the change in the energy. Change in the energy with respect to the change in system. With respect to change in system. The change of energy with respect to the change of system. And here, that is the potential energy, and it changes to another system. Again, the potential, maintain the potential, again change system. Again potential, again change system. Again potential, again system. That means at each stage, some energy is released in the system. And that is unutilized. That is unutilized energy. And when the energetics level is decreased, it is responsible for the increase of randomness. Increase of randomness or entropy. Or entropy. Randomness or increase of entropy. Clear? Third one, यहाँ पे आप आइए, gives free energy. Graph for the gives free energy. Gives free energy. Gives free energy. And for the proper understanding of the gives free energy, that one is the delta G dg is minus RT IN or natural log whatsoever K equation. K equation. That K equation represents the molar ratio of, that is ratio of molar values of product to reactants. Molar value of product to reactants. Then here the delta G, if it is negative, then it represents the movement of the equation from left to right. Forward. Left to right. That is product, reactant to product. And if dg is positive, then right to left. Right to left. And in some books and in some representation, both are represented separately, independently in the graphical forms. But here, I am writing here that this one is the change of energy with respect to time in second. Here, suppose the reactants that is A plus B is equal to 100%, and here product that is C plus D is 100%. C and D is 100%. Here A and B is 100%, and here C and D is 100%. With respect to the time, this one moves from here to here and then here. This one represents the equilibrium. This one represents the equilibrium. Here dg is less than ki more than, क्या होगा? What one? Less than 0 or more than 0? Less than 0. Less than 0. And K, that is kinetics. K, then what is the effect on K? Is more than 1. Is more than 1. Is more than 1. Here, delta G is, here delta G is 0. Here delta G is 0. And K is 1. Yes, very good. Here delta G is more than 0. And here K is less than 1. Less than 1. It is the graphical representation of the Gibbs free energy. It is the graphical representation of Gibbs free energy. Clear? Third one is the rate of equation, EQ. Reaction coefficient. That is, here it is equivalent to product 1, product 2, reactant 1, reactant 2, A, B, C, D. That A, B, C, D represent the molar value. That A, B, C, D, A, B, C, D represent molar value, molar values. That represents the molar values. And one thing again I am saying that the G naught, differences of the G naught, that is the change in the Gibbs free energy, is only determine the spontaneous of the reaction. It does not represent the rate of reaction. Always remember that Gibbs energy only determine that the forward reaction is spontaneous or not, but it never determines the rate of reaction. The rate of reaction is the part of enzyme kinetics, which we will discuss in later on. कभी कभी ये क्वेश्चन पूछ देता है, वहां पे लड़के कंफ्यूज कर जाते हैं. तो डी नॉट जो है, द गिब्स इक्वेशन, फ्री गिब्स एनर्जी is only determines the direction of the reaction. Only determine the direction of the reaction. It does not determine the rate of reaction. Rate of reaction को ये determine नहीं करता. Then the suppose the D energy, the two system, the change in energy, that is change in the dp and change in the r, reactance, product minus reactance. यहाँ पे फिर कंफ्यूज नहीं करना जी. क्या नाम है उसका? रोशन. रोशन क्या नाम है जी? रोहन. हाँ, फिर नहीं बोल देना कि सर ये आप कैसे लिख दिए. That is minus d r, that is the reactance. That is the reactance. And here I also mentioned in my last class that the dg not बराबर minus 2.303 RT Roman होगा EQ. Clear? Again, when it is neutralized, then dg बराबर minus RT IN E. Sorry, 1 minute. This one. And when it is present in the form of H plus ions, that is the, because in the biological system the reaction is pH dependent, and if you anyone ask the questions on the basis of the pH, then the same nature is converted. There is no any. Then the GIN, that is for the H, minus RT in KEQ divided by H plus. And here in my last class I also said that this one is calculated. This one is calculated. कितना बताया था? What's value? What's value? ये दोनों में हो सकता है, कैलोरी में भी हो सकता है, कैलोरी में भी हो सकता है, और जूल में भी हो सकता है. मे बी आस्किंग द कैलोरी एंड मे बी आस्किंग द जूल. तो कैलोरी में क्या बतलाए थे हम इसका? 1 पॉइंट नहीं है, पॉइंट नहीं है. 1364 कैलोरी पर मोल पर के. कैलोरी पर मोल पर के एंड 1.36 किलो कैलोरी. अगर ये किलो कैलोरी में है तो 1.63 किलो कैलोरी पर मोल पर के. If at the 25 degree centigrade, at the 25 degree centigrade, and in the condition of the 37 degree centigrade, 1419 calorie per mole per K, and if in the kilocalorie, then 1.419 kilocalorie per mole per K. Clear? But if it is present in the form of joule, then it is not in the calorie. If it is mentioned in the form of joule, then 1 kilocalorie, 1 calorie equivalent to the joule. Equivalent to the joule. What? कितना joule? 4.2. 4.2 ने 4.1, हाँ उसी के लगभग है. 189. 4.18. So now the value is multiplied by the 1.489. Now probably it comes at the 8 something 8134 probably. 8314 like this. 8314. Whatever you calculate in the method when they asking the question. आप इसको calculate कर लीजिएगा. But you must mention, you must care during the calculation that you consider the units. जिस समय आप बना रहे हैं एग्जामिनेशन में या प्रैक्टिस कर रहे हैं तो आपको यूनिट्स पे ध्यान देना है. क्लियर? 1 minute. This one, यहाँ पे I am just on कर दो. This one I just miss here. It is the value of this value R, gas constant, in the joule. This one is the value of the gas constant, that is 1.98 multiplied by 4.189. This one, that is the value of R. Here, the joule is converted into the accurately 5,700. 5,700 joule per mole per K. Now, another form, and that is important, that is Vent half equation. Vent half equation, or another way, Vent half equation or graph. Vent half equation or graph. Then we have two equations for the calculation of dg. One कौन सा है? dg in the form of enthalpy and entropy. Yes. Delta H minus T delta S. Second one is in the form of reaction equation. What is the formula? Minus RT in K, this one. These two, we have these two formula for the calculation of change in energy. Change in energy in any system. Then, in the change in energy, if we write the minus RT in K EQ, that is delta H T delta S. Then have any problem? No? लिखिए नहीं, पहले समझ लीजिए फिर लिखिएगा, नहीं तो दिमाग वगैरह में घुसेगा नहीं. हम जो बोर्ड पर लिख रहे हैं वो बीमारी छोड़िए कि बोर्ड पर लिख रहा है साथ साथ लिख रहे हैं, समझ में नहीं आएगा, फिर लगेगा बाद में गाना गाने. This one is equalized here. Now RT natural log KEQ minus delta H plus T delta S. Is it clear or not? ठीक है? Now K minus delta H plus T delta S RT. Then have any problem?
No, sir.
Then in KEQ minus delta H RT plus T delta S RT. Have any problem?
No, sir.
No. Then this one is struck out. That is minus delta H RT plus delta S R. Have any problem? Minus delta H R multiplied 1 by T plus delta S R. Have any problem?
No, no, sir.
No. That means in KEQ, and here it comes like that. In, that is the natural log KU minus delta H R multiplied 1T plus delta S R. Clear? This one represented on the y-axis. Okay, that is y. That is M. That is M. That is X. That is C. देखो ऊपर क्या है इसका मतलब. That is x axis, that is y axis. Sorry, this is y axis, this is x axis. That represents change in the enthalpy with respect to the change in the gas constants. This represents the change in the entropy with respect to the change in the gas constant. And when we consider R constant, when we consider R constant, R is the constant, then the one axis is the y axis, it represents n k kinetics, logical kinetics. This one represents the 1 by t, this one, that is the x, and a line is comes here. The intercept, that is the intercept represent what one? Delta? Delta S by R, and the slope represents delta H by R. This one is referred as the Van 't Hoff equation. Clear? सेकेंड, इसमें जो यहाँ पे क्वेश्चंस आते हैं, एसोसिएशन एंड डिसोसिएशन कॉफिशिएंट्स. एसोसिएशन एंड डिसोसिएशन coefficients. Association coefficient is represented by Ka and dissociation coefficient is represented by Kd. And sometimes question asked on the association and dissociation coefficient. And in the biological system, a number of association and dissociation is associated with the receptor molecules and ligands. Receptor molecules and ligands. That is receptor site. Receptor site, and that is the number of ligands. Receptor molecules and ligands. Like for example, enzyme and substrate attraction, the antigen antibody attraction, the attraction of the hormone for the receptor surface. All these are associated like this. Then here it is simply represented, not anyway, that is the receptor and ligand. Receptor ligand complex. Receptor and ligand complex. And it is generally on the basis of the mass action. This one is the A, that is the association, and this one is the D, that is the dissociation. Ka represents the association, this direction, and Kd represents the dissociation. And suppose if the association, that means it is the reactant and it is the product. It is the reactant and it is the product. Well, they are the reactants and it is the product. That means the molar concentration of Rl, matlab receptor ligand complex, divided by molar concentration of ligand. Molar concentration of ligand. And here, that is, in this way, this one is the reactant and this one is the product. And here, that is opposite in direction, that is R, ligand, divided by molar concentration of Rl. And when the Ka value is increased, it is clear that if the association is increased, that means there is more chance of the formation of the RL complex. RL complex. And when the value of the Kd is increased, then there is more chance of the formation of the products. That is the dissociation. That is dissociated in the form of the reagents and receptors. And only these are the kinetics value, nothing else. बाद में इसको देखा जाएगा. यहाँ पे इसका इतना ही मतलब है और इससे ज़्यादा कोई मतलब नहीं है. देखिए, इन लास्ट क्लास हमने आपको बोला था कि बायोलॉजिकल सिस्टम मतलब लिविंग सिस्टम में जो थर्मोडायनेमिक्स का रूल है, बोले ना कि वो क्योंकि ये ओपन सिस्टम के रूप में आता है, वाई सो द इंथैल्पी, हम बोले थे कि उस समय बोले थे कि देयर नंबर ऑफ कॉम्प्लेक्सिटी इज डेवलप्ड इन द बायोकेमिकल मॉलिक्यूल्स, बट it is against the rule of the thermodynamics, because if the entropy is increased, it is responsible for the increase of randomness. That is randomness means that is disorganization of the molecular structure. Disorganization of the molecular structure, that is increase the randomness of the molecules. But here we observed that the complexity is increased. In last class I told that complexity is maintained by the open system of the living, open system of the living body, because it is responsible for the exchange of energy and matter with the surroundings. ठीक है? But if you consider the universe as a whole, then entropy is increases gradually. Then entropy is increases gradually. But here, the most important factor which is responsible for the conservation and utilization of the energy in the living system, conservation and utilization of the living system, because as per the thermodynamic rules, the 100% efficiency on the basis of the energetics is not possible. अभी हम लोग जितना पढ़े, जहाँ तक समझे, वहाँ से ये स्पष्ट है कि energetically the 100% efficient system is not possible. 100% एनर्जी कन्वर्ट कर जाए कहीं, ये संभव नहीं है. अगर ऐसा होगा तब क्या हो जाएगा? इंट्रॉफी जीरो हो जाएगा. तो ठीक है, कहीं कहीं इंट्रॉफी जीरो हो सकता है, लेकिन पूरे सिस्टम में इंट्रॉफी जीरो हो जाए ये संभव नहीं है. इंट्रॉफी इज ग्रेजुअली इंक्रीजिंग, बट इन द लिविंग सिस्टम द मोस्ट इंपॉर्टेंट फैक्टर विच इज रिस्पॉन्सिबल फॉर द factor which is responsible for the conservation and utilization is the coupling system. Coupling method. That is the coupling method, referred as the coupling method. That coupling method is responsible for conservation and utilization of energy in living system. Living system. In living system. Now, what is coupling system? I am describing here the coupling system on the broad basis, मतलब broad level पे हम यहाँ पे बतला रहे हैं. But in the each energetics, each enzymatic reactions, either you study the Krebs cycle, or you study the glycolysis, or you study the ATP synthesis, or you study any complete anabolic and catabolic pathway, that is associated with the coupling method और कपलिंग सिस्टम, कपलिंग मेथड और कपलिंग सिस्टम। I am just here describing as a whole, as a whole. Then I also write here that the energy is produced in the living system by the commonly by the method of the oxidation of glucose. Oxidation of glucose. That is C6H12O6 plus 6O2. 6O2, then 6CO2 plus 6H2O, then DG H minus 686 kilo 686 kilo calorie per mole. 686 kilo calorie per mole. Here the energy is released in the system. Energy is released in the system. Again, we come on the another side that the glucose is responsible for the breaking to the carbon dioxide and water. Now, another way, the glucose is synthesized by the plants by the process of photosynthesis, and here it observed 6 CO2 plus 6 H2O, that C6H12O6 plus 6O2 DG, that is plus 686 kilo calorie per mole. Clear? With respect to this one, but if you consider the independently, we consider the independently, that the reaction is forward here and the energy is maintained by the solar energy. Solar energy. And only 1% of the complete solar energy is trapped. Only 1%. Only 1% of the solar energy is trapped. When this one is released, 686 is released, then the 686 is utilized by the living system in the synthesis of ATP. Utilized by the synthesis of ATP. That means the ATP is synthesized by the ATP. That is from the ADP to ATP. ADP is converted into the ATP. And here the phosphate group is responsible for this phosphate is responsible for conservation of 7.2 kilocalorie. This one is responsible for 8 kilocalorie, and this is the lower, that is the 3 kilocalorie. That means thus some parts of the energy is converted into the further potential energy. यहीं पे समझना है, फिर हम बोल रहे हैं पहले समझ लो फिर लिखना, तो तुम लोग को बीमारी है। यहीं पे मेन बात है कि द पोटेंशियल एनर्जी इज फर्दर कन्वर्टेड इनटू द पोटेंशियल एनर्जी। ये हीट में कुछ जा रहा है, क्योंकि हम बोल चुके हैं कि दैट इज नॉट 100% इफिशियंट, दैट इज द इनर्जेटिक इफिशियंसी। इसमें भी कोई क्वेश्चन आता है, दैट इज द इनर्जेटिक efficiency. and that means here the energy released is responsible for the ADP plus PI to ATP. ठीक है? How much? 38. This one the 38. That means 38 multiplied by the 7.2 kilocalorie is conserved in the potential energy. Is conserved in the potential energy. That is conserved in the potential energy. Clear? Then in this process also some ATP is utilized. अगर आप फोटोसिंथेसिस पढ़े होइएगा तो आपको याद होगा. Some ATP is utilized. That means ATP is breaks in the ADP and PI. And probably 18 ATP is utilized in the C3 plant and 20 ATP is utilized in C4 plants. That means this phosphate bond is responsible for the coupling system, formation of the coupling system, and prevents the much rate of the entropy. Entropy का जो maximum rate होता है उसको ये क्या कर रहा है? Prevent कर रहा है, रोक रहा है. And that is responsible for the more and more complexities. ये जो सेलुलर सिस्टम में जो कॉम्प्लेक्सिटी डेवलप करेगा ये इसको क्या करेगा? माने करने के लिए उसको मदद पहुंचाएगा. यानी जो इंट्रॉफी का इफेक्ट यहाँ पे होना चाहिए था वो उतना नहीं होगा. एंड जस्ट आई एम रिप्रेजेंटिंग हियर दैट मीन्स द फॉस्फेट बॉन्ड इज रिस्पॉन्सिबल फॉर द कपलिंग मेडिएशन. कपलिंग मेडिएशन कौन कर रहा है? फॉस्फेट बॉन्ड. ठीक है? आई एम जस्ट हियर रिप्रेजेंटिंग एट द ग्रॉस लेवल. हम इसको कहाँ पे बतला रहे हैं? एक बहुत बड़े लेवल पे हम बतला दिए. बट in the each system, if you observe the different stages of the enzymatic activities, जैसे आप क्रेब साइकिल पढ़ रहे हैं तो क्रेब साइकिल में एसिटाइल को एंजाइम ए से लेकर फिर वो एसिटाइल को एंजाइम ए जहां तक बन रहा है क्योंकि वो साइक्लिक है. Then you utilize consider the complete system, that the energy consumed and energy released. That means here the 7.2 into 38 whatsoever जो भी वैल्यू होगा is the percentage of the 686. That is the percentage whatsoever. अगर x आ रहा है तो इसका ये जो परसेंट होगा that represent the energetic efficiency. That represent the energetic efficiency. ये energetic efficiency को बतला रहा है. Why so? The anaerobic condition is, or anaerobic, earlier organisms were the anaerobic, but the energetic efficiency is more in the aerobic condition. That is mainly responsible for the evolution of the anaerobic condition to the aerobic conditions. Clear? इस पे कोई क्वेश्चन आएगा तो बन जाएगा. कपलिंग प्रोवाइड कर रहा है कौन सा? फॉस्फेट. ठीक है? एंड ईच स्टेज इट इज रिस्पॉन्सिबल फॉर द कपलिंग एक्टिविटीज. हम तो ये ग्रॉस बड़े लेवल पे बता दिए. ईच अगर एक एंजाइम की भी एक्टिविटी हो रही है तो वहां पे कहीं ना कहीं वो कपलिंग में जाएगा. एंड दैट इज द एसोसिएटेड विद द फॉस्फेट बॉन्ड. ये फॉस्फेट बॉन्ड के द्वारा ही मेडिएट होगा. क्लियर? लास्ट वन इज द थर्ड लॉ ऑफ थर्मोडायनेमिक्स. क्या बोलता है ये? थर्ड लॉ ऑफ थर्मोडायनेमिक्स. बहुत सिंपल है. क्या बोल रहा है ये? इफ द के जीरो, के मतलब केल्विन, टेम्परेचर इज जीरो. वेरी गुड. then it represents the maximum stability. Represents the maximum stability. It represents the maximum stability. It represents the maximum stability. Then K 1. क्लियर? कोई दिक्कत नहीं, बंद करो.